Aghlara, and Arash is the CEO and the founder of Lex Rules, one of the popular decision intelligence platforms. He lives in Australia, but their products go far beyond Australia. And recently, Arash wrote a lot about decision intelligence and shared his real-world experience. So I believe that Arash is the right person to explain and demonstrate how DIPs, or our decision intelligence platforms, distinguish themselves in the modern world. Arash, take over.
Thank you very much, Jacob, for the nice introduction. Hello, everyone, and I'm very pleased to present this conference this year and be part of the expert panel this year. So let's get it started. I have experience in implementing complex decision intelligence project across many different industries with many different use cases: product configuration, dynamic pricing, credit decisioning, fund management, eligibility, etc. Now, based on this experience around these projects, and the fact that 80% of the AI projects are failing, which is a significant rate based on the RAND report, I decided to talk about the best practices and things that I learned during this implementation across enterprise organizations, generally in BFSI, industry and government and health, to make sure we don't contribute in this 80% failure from now on. And we can make sure that our organizations and the customers and clients we work with get the most out of decision intelligence. And that really was the driver of this presentation. So I'd like to start this with a story, The Elephant in the Dark. Rumi, the great Persian Sufi and poet, has a story about the elephant in the dark. And the story goes like that. So if we put an elephant in the dark room and we send people in the dark room and they try to identify what creature is in that dark room with feeling and touching different parts of the animal, they will have different assumptions based on their experience. If someone touches the tail and pulls the tail, they may think that is a snake, or if someone touches the ear, they may think it's a giant bird or big butterfly, or feet might feel like pillars. So depends on their experience, they will have different assumptions. Now, the reason I share this is because the story of decision is exactly like that, particularly in decision intelligence, when we have many different stakeholders and many different professionals along the project. So one of the things that we noticed is that in order to make sure the decision intelligence goes the right direction, we need to have a methodology based on decision-centric approach, which is generally has 3 stages: design, automation, and operationalization. And I'm going to share a couple of best practices and things we learned for each of these stages. So because of the nature of the decision and decision intelligence itself, because it was evolution through, as Jacob also mentioned at the beginning, through different technologies, through different practices and disciplines, we came to the place that nowadays people, if they don't have, like ourselves in this particular community, small community, I'd say, if they don't have experience with decision, they may think decision is something similar to what they know of, based on similar to the story of the elephant in the room. Decision intelligence is about decision, and when I'm talking about decision, I'm talking about the business decision. Hence, if people come from different areas, like we have in our projects, people coming from process, and they think, okay, why not model decisions in terms of process and have gateways and all of those fun stuff? Or people from business rules area, they think business decision is business rules. I had many conversations over online speaking engagement and customer-client relationship about data analytics and dashboard and data democratization and literacy. And they think better data and better quality of data makes them able to make better decision. Hence, the data is decision, or dashboard is a decision. We almost certainly talk a lot with data scientist teams that they believe machine learning and algorithmic decision, which is quite opposite of what they believe. And all of these assumption is because this field pushed the boundaries of technologies and product categories, and now we're calling it decision intelligence, and has many different people and experiences and from different fields involved in this. So the first thing is for ensuring that we understand what the decision is and how to model the decision, we need to make sure we are not using any irrelevant techniques or notation or even proprietary notation for modeling the business decision. And what we came to conclusion is decision model and notation, which we believe, but outside this community, is not so much popular, is the best option for modeling business decisions. Now, the first and most important part of experience and what we need to talk and socialize between the project groups to make sure we get the impact for organization, and I'm going to talk about that in a moment, is to make sure we explicitly model business decisions using open standard decision model and notation, not proprietary notation or process notation or anything else. So that's the first best practice, which is, we may feel that's very obvious, but outside of this community, unfortunately, it's not. And the second part of decision intelligence is intelligence. Is not very profound. So the first part is decision and second part is intelligence. But when we're talking about intelligence, and Jacob had a quite interesting take on this. So do we really mean intelligence in terms of emotional intelligence, in terms of creativity, in terms of problem solving? There are many angles and frames to the word of intelligence. Now, if we look at the adoption of the decision intelligence, it happens mostly in regulated environment and dynamic organizations operating in those regulated environments. And this narrows down to a very specific needs for intelligence. It should be based on domain expertise. It has to have the knowledge, embedded knowledge for operation and market knowledge. And it should evolve during the time and get mature over the time as we go on. And these requirements for intelligence needs design doesn't happen by accident. Now, in order to design this intelligence with these three characteristics that helps organizations, dynamic organizations in a regulated environment, in changing environment, use AI for decision making, we have a framework called decision intelligence architecture, which helps them to get their head around, okay, so how do we trust this model? At what level do we add, for example, LLM, or at what level do we incorporate the uncertainty of the changing environment, and so on and so forth. So decision intelligence architecture allows them to put framework around designing intelligence for enterprise organizations operating in the regulated environment, which is banking, finance, government, health, insurance, and all of those generally bigger corporate organizations. Now, I'll go quickly touch on a couple of these layers of decision intelligence architectures. It has 5 layers, 2 of them very fundamental and foundational to the rest of them. So we start always with the knowledge core and then intelligence core. And then on top of that, we build expert intelligence, cognitive intelligence, and autonomous intelligence. Now, when we're talking about knowledge core, this is the core foundation for organization knowledge. It captures explicitly the terminologies, definition, concept, facts, and more importantly, business decisions that organizations make and execute. This explicitly capturing models of the decisions and fundamental around those business decisions includes the knowledge of domain expertise, operation, and market they operate. Now, the next level of the intelligence is intelligence core, which enables organizations to build the first intelligence level based on the knowledge core they captured previously, using business rules and formulation and procedures. This is a little bit significant to organizations because when we talk to customers, they're like, okay, how do we trust this AI? And recently, there was a publication that talked about the hallucination on the LLMs, and I'm sure many of are aware that that kind of hallucination is not necessarily a defect for that kind of approach. It's the byproduct of the design and architecture. And when we put that in the context of a regulated environment, it always becomes scary for our clients to trust that kind of AI. And this is where the symbolic AI becomes significant in terms of gaining that trust. So at this level intelligence, 100% explainable, reliable, safe to deploy in critical operation, and operate in the regulated and dynamic environment. Now, after this level, we get to the layers of more, maybe from the practitioners, more interesting combination of different techniques. Now, this is where we call expert intelligence. On top of the previous layer, it enables organizations to build intelligence that interacts with the environment, senses events, captures data. Essentially, we build agents, expert agents, that can reason and make sure the outcome of those decisions are optimized. More importantly, the decisions made at this level are optimized for goal and have a level of intelligence and ability to reason and plan. Now, on top of this level, we can deal with, we can add up layers on top of the layers to make sure we get to the point that everyone generally likes, but they start from the end of this design rather than starting from the beginning. And again, I want to emphasize that this decision intelligence architecture gives them the guide and principle on how to design that intelligence that can be trusted in regulated environment for making decisions. Now, this level is called cognitive intelligence. It enables organizations to make decisions based on future events so they can incorporate uncertainty, forecast, and things that has not happened yet as part of the decision-making models that they built. And we can use many different techniques here using, for example, value prediction, classification, regression, etc. And the last one that we generally talk about is autonomous intelligence, which at this level, this is the agent that on top of the previous one, which was interacting with the environment and executing and becomes really a self-sufficient agent. Now at this level, that self-sufficient agent has a self-learning capability, which enables those agents to learn based on the impact of already made decisions, not any data. Sure, data is needed and everyone knows it, but most importantly, that feedback loop incorporates the impact of the decisions already made to the agents and allows them to improve that over the time so the decisions they make are better and better every day. Now, with this 5 layers of architecture, decision intelligence architecture. What we can deliver is intelligence by design, which incorporates the domain expertise, operation, and market knowledge for organizations that operate in the regulated environment, and they are very dynamic in terms of personalization, responding to the market. Now, that was the 7 best practices on how to talk about intelligence and design intelligence that they can trust. So that was part of the decision intelligence architecture. We talked about the cognitive intelligence and expert intelligence, which requires essentially a model that incorporates multiple different techniques. And this is the part that it gets very interesting and everyone becomes excited about it. So a composite AI is a way that you can incorporate multiple different techniques of business rules, machine learning, optimization, constraint programming, and etc. And also data access processing as part of one holistic model for decision execution, a decision model that is executable, and it incorporates multiple different techniques there. Now, the best way to design this model is to distinguish between decision and orchestration, the design principle of separation of concern. Sure, we need orchestration, sure, we do decision modeling, but mixing them as part of one big model is not going to work out well because of the complexity increases exponentially. So I get question that I keep repeating about the regulated environment. I'll answer that in a second when I go to question and answer. Thank you, Alex, for asking this. Now, this separation of the concern allows us to first build a composite model AI that is based on decision requirements diagram of a DMN. We use the same principle, decomposing a complex business decision to smaller, easier to understand, reusable decision units. And this is how it looks like. Now, there are certain things that we need to add on top of the decisions requirement diagram to make sure that it can reliably and easily work with different techniques in terms of the decision units. But we get to that point in a minute. Now, this decision graph is based on the decision requirement diagram, which represents a composite AI model. How? So similar to a decision requirements diagram, you need to define the input. So the structure of the input, the relationship of the input, the constraint around the input, and all of that. So once that input is defined, then each decision unit in a decision graph can be implementing different ways of decision. In this particular case, we're going to calculate the health premium, the COVID requirements of the health premium is using the decision table. Now, decision requirement diagram, which is a kind of a decision graph, a simplistic version of it. But now in the decision graph, you can have situation-aware decision. You can have events. You can process different things. Now, one of the benefits of the decision requirement diagram is that allows you to pull together different implementation. So for this instance, for example, income is using another forms of rule modeling, natural language, to implement the rules around income. Now, this is where it gets interesting. If you look at the base price calculation, now this decision graph, which representing a composite AI, combining multiple different techniques, it actually incorporates a regression model that does the base pricing as part of this decision making for calculating the health premium. Now, this regression can be bring your own algorithm and integrate it into here Your platform might be able to train the model. However it is, now with this decision graph, you start combining more than business rules. You're incorporating machine learning. For this example is a regression model that is incorporated. Now, the other nodes of this decision graph can incorporate, for example, optimization and so on and so forth. The point of having a decision graph and what we learned is we need to make sure that decision model, first, the separation of the concern, decision model from orchestration, and then second, of that point is that decision graph should contain all of it. Yes, you can separate the machine learning execution part, put it as part of the orchestration, or do it before and pass the values to decision model out. But that breaks one fundamental point of composite AI, which is that decision model is a holistic model for every component of the decision making. And it makes it easier when you look at it. It makes it more explainable as it is composable, and you can say at certain point what happened, and it gives you more visibility and transparency in terms of how did we make this decision when everything is inside that decision graph, including optimization, business rules, machine learning, and so on. So decision graph should contain it all. So the other part of this design principle was the orchestration. So we separated decision and it contains all of different combination. And now the second part is orchestration model, which there are many different ways of doing orchestration. That's very interesting because sometimes, and we see quite a lot, that this orchestration becomes a coding practice within the team, whether data scientist team using Python or whoever uses whatever the coding language and programming language they're familiar with. And as also Jacob mentioned, now the point of decision intelligence is to make sure non-technical people can do it all. And then orchestration component of the decision intelligence becomes important because now we have an agent that requires to communicate with different agents. So it requires orchestration between agents. It requires to go and grab data from operational database. It requires to ask human to give the input to overcome the inconclusive outcome of some part of the decision graph. So you can see now all of a sudden bringing every component together requires an advanced orchestration. And you'd better to have an advanced orchestration in terms of a visual way rather than the coding, because with DI tend to target more non-technical team, such as operation, SMEs, BAs, and so on and so forth. Coding approach in orchestration generally poses constraint in terms of understanding and delivery and all of the good values that we require to deliver that impact for organizations. And speaking of orchestration, there are so many things can go wrong with orchestration. Generally, we need to make sure orchestration is one of the most reliable components of the solution. Therefore, that means when you integrate with data and services and stuff, you may not receive, for example, the response time in the same thing that you expected to receive because service is busy. They can't send you the result, particularly when you're interacting with orchestration to communicate with external services and online services. So you need to make sure that resilience and retry and exception handling are built in as part of your orchestration to make sure that doesn't fall into the crack. And as the result, the decision can create the outcome reliably. And orchestration is a big thing to make sure that reliability is built as part of orchestration. Now, baking reliability as part of the orchestration to incorporate human overriding a decision or adding extra information or providing the context or communicating with application and IT systems and processes and workflows and so on, that has exception handling, resilience, and retry should be part of that orchestration. The last stage of decision-centric approach is operationalization. And what we're saying many times is this stage as operationalization is dumbed down to just deployment. So we deploy this to a service or whatever it is, and then we call it operationalization. However, there are many different points in operationalization can go wrong. I just pick a couple of more important ones and how we can tackle them, and then we wrap it up quickly. Now, as part of operationalization, DI requires cross-team collaboration. And if the repository that we manage decisions are not the repository generally is used in organizations, that makes the cross-team collaboration very hard. Now, the best thing to do to avoid this is to make sure that repositories of decision are generally the one that organizations use. And what are those centralized repository for artifacts that they use in building systems? Git, any type of Git. So if we can make sure the artifacts of decision intelligence project are managed with centralized repository of Git, that makes the collaboration way easier in terms of many different aspects of the collaboration, including the deployment and automatic deployment. And speaking of the deployment, hence we want to make sure decision intelligence projects are managed in what we call decision ops. Decision ops has more responsibility than the DevOps. But essentially, we need to make sure that deployment of decisions, the whole solution as the decisions, orchestration, and other components can be done within the decision ops team, which they're not literally software developers or IT architects and all those big brain people. Now, in order to make that happen, we need to make sure deployment also can be handed over to this decision ops team. And the reason is we don't want to wait for IT and software development team to deploy and incorporate the decision model into the organization and operationalize it. And hence the changes happens. They need to do quite often deployment of the change themselves. Now, speaking of the change, you may deploy the decision, okay, fine, but rule changes, data point changes, decision will be updating. Now, how can we make sure that we still get the best outcome from the decisions? You cannot go like big bang, the latest version of the decision is the best version. We don't know. The impact of the decisions are very hard to measure and requires certain amount of time to look at the outcome and understand whether this particular, for example, discount policy increase the revenue of organization or not at the end of the season, right? Now, therefore, we need a way to securely and reliably roll out new versions of the decisions gradually. Now, that falls into the umbrella of adaptive control. So we might use a strategy like champion challenger to have a waiting on the new version rolling out gradually, or in some environment like in calculating tax, we need a very specific deadline that the next version automatically rolls out. Now, all of these, what version and how we want to roll out, and based on the time or metadata or whatever it is, falls in the umbrella of the adaptive control, which is part of the operationalization. So if we dumb down operationalization, we will miss out on many things that we need to worry about, and then we don't know where to fit them. Now, the last one of these best practices is do not dumb down operationalization to just a deployment, and make sure that all of it, collaboration, rollout, deployment, all of those activities can happen in the decision ops team, and reduce the reliance on IT and software development team. And now let's summarize what we discussed here. Now, the two big part is having a methodology, decision-centric approach, designing intelligence, decision intelligence architecture, and within these two, explicitly designing business decision using DMN, not a proprietary or other notation for decision. Do not dumb operationalization. Make sure orchestration are reliable and visual, and composite AI, the decision graph should contain it all, including machine learning, business rules, different types of it, and optimization. And with that, my presentation is done, and I'm open to answer any question.
Okay, great. We do have a question by Alex and about the regulated environment. You promised to answer this question, and I want to ask everybody, it's not necessary to type questions, just feel free to unmute your mic, turn on your camera, and ask questions. We do have time for them. Arash, you can answer the question.
Yes.
Of Alex.
So the question is, if we keep, I kept referencing regulated environment. What if your customers are not in regulated environment? Would this model still apply? I still apply the same model in non-regulated environments simply because it reduces the complexity and it's easier to digest. For example, the decision intelligence architecture allows you to design based on the decision model and notation, start building the foundational knowledge of organization, then add one layer on top of another layer on top of another layer to get to the intelligence you want. You don't necessarily need to be in a regulated environment. However, if you apply that in non-regulated environment, you still get the benefits. For example, having a trust in the automated decision from the client's point of view is generally hard, but with showing them how this intelligence builds up until the level that they want to build up, that gives the confidence to the clients to use more of these automated decisions for the matter of the accuracy, consistency, and transparency.
Okay. Any more questions? Please unmute yourself and ask. Okay, we can have question in the chat. You can read it and answer.
So the next question, Lynn asked about, are executive trained well enough to take the time required? Well, the answer is no. They don't have time to get trained. And that was one of the discussion we had with some senior executive that they ran the data literacy in one of the largest insurance company in the US. And for this fact, the concept of the decision ops team becomes very important. So they don't need to you don't need to train the executive on the whole decision intelligence, different levels and stack of technology. They need to be understanding what is important for their organizations. Now, the training part of it, it's mostly goes toward the decision ops team, which they're going to operationalize and build and do these models. So this architecture and this approach actually gives the executive the opportunity to learn what they need to learn and separates the learning programs for decision ops team that they needs to be hands-on and so on and so forth.
Okay. More questions, please? Okay, you got another question from Elena.
So the question is it possible to use knowledge graph, taxonomy plus ontology as input? Everything is possible, but we need to make sure that where does that fit in terms of the project we want to build. Generally, I didn't cover this particular taxonomy plus ontology as part of the decision intelligence architecture because different organizations use different references for different terminologies. But that can go to the knowledge core, in my opinion. And that the answer is yes, as part of the knowledge core, which we capture the organization knowledge, that taxonomy and ontology is part of that organization knowledge as an input.
Alex raised hand. Alex, unmute yourself.
Great presentation, Arash. I had a question. I didn't hear much, perhaps, on automation. I was just curious. What in your experience are you seeing customers? How does this relate to their automation journey? I was just kind of curious on your take on that.
Can you elaborate on the question a little bit, maybe, please?
Yeah. And so I guess where I'm going with this is that I was curious if you're seeing customers using this approach to help them automate more of their decisions.
Yeah.
And are they getting there, or is it more to help? Maybe it's to guide them to understand more how to make the decision. So eventually, and so I guess what I'm trying to get to is, over time, is it more hands-off, full on, like more of an autonomous mode? I just kind of curious, sort of where are you finding these different paths that your customers are moving towards with this that might be further along in their journey?
Yeah. No, that's an excellent question. That was part of the reason we came up with this whole decision intelligence architecture, because based on the ambitions of the clients. So let's talk about the automation. Second stage of the decision-centric approach is automate, right? Now, depends on the ambitions of the organizations. Some organizations get very frightened in terms of automated decisions. Some may not. And then depends on their ambitions. You can go all the way up to the autonomous intelligence, which was part of the decision intelligence architecture, or make it down to just rules automation. So what I'm trying to explain is it changes based on different conversation. Even within one organization, you talk to different stakeholders of organization, they still feel they need different levels of that intelligence, and hence that decision intelligence architecture helps to not only gain the trust in terms of, okay, you're in control where you want to go. You don't need to go automated decision all of a sudden in the autonomous part. You can go step by step, gradually, baby steps toward whatever the ambitious is, and then also give them kind of a plan of work where they are and where they want to go and what they need to achieve in between to get there.
Okay, thank you. More questions? In this case, I want to get back to the question what Elena said about ontologies and RDFs. And you did not mention in your presentation, and there are serious reasons for this, and I just want to make comment about this. Pay attention that our event goes together with our co-event, RuleML. And RuleML, this is one of the major organizations for semantic webs, and they talk about ontologies and taxonomies over there a lot. And this is extremely serious questions, and it goes much closer to real understanding and to more to AGI questions, what we will hear about tomorrow from Peter Voss, but I want to tell you that we're trying to do this integration between RuleML and the decision management community for years. And more than that, even some academicians from their community created a converter from RDF to DMN. You can see the work of Professor Dumas, and I can give you some links if you're interested, but it does not go beyond academic research. So far, it does not. But still inside, many people, and Denis Gagne, one of them, can tell you more about how they use RDF inside. And I really hope that we will see more links in the future. Because if we're talking about intelligence, that's the place which we cannot ignore.
Absolutely.
Okay, any other comments or questions? Okay, in this case, Arash, thank you very much for good presentation. And you can ask more questions in the chat, and Arash would be happy to answer them. And let's move forward. Thank you, Arash.
Thank you very much, everyone.
Okay, I will stop recording and